Hey, good morning, everybody. My name is Jens Mönig, and I'd like to talk about a powerful idea that changed my life. And it's all about building things with blocks. Anybody, you built things with blocks, with wooden blocks as a kid? When I was little, my dad actually made these blocks. These are the very blocks I got off my attic last night. And, we found out, my friends and me, that they were perfectly matched to accommodate Playmobil figurines. You know Playmobil figurines? So we were spending hours and days to, build forts, bridges, could turn them into, pirate ships. Whatever you could imagine. And I was actually, I'm a little, almost ashamed to admit it, I was playing with these blocks well into my teens. And to just, run wild with imagination. Then school happened, and I pursued other dreams, and it always was my dream to become a lawyer. Because look, as a lawyer, you get to really do cool things, and most of all, you get to wear this Harry Potter robe. And it's a powerful thing because literally an attorney has power of attorney. Anybody know what that means? It's the capability to act on behalf of somebody else, to kind of be in their role and to bring about change for somebody else. So I was fulfilling my dream. I was working as a lawyer for a dozen years, and then I switched profession. And I laid off that robe, and I became a computer programmer. Daytime, I was building enterprise software for companies that manage contracts for telecommunications. But at night, I was working at this crazy thing that I discovered, that is Scratch, a programming language for kids. Anybody know Scratch? Everybody knows Scratch, right? You've all used it. Now, the cool thing about Scratch was, look at this. It's a language that uses blocks to build things. Not forts, not pirate ships, but veritable computer programs. But they get assembled in much the same way as I did as a kid. So one of my first projects while I was working for, get this, the Lifelong Kindergarten group at the MIT Media Lab was, how can we extend Scratch, the language itself, with blocks? And my project was to create something that I called build your own blocks. So we take blocks and we turn them into other blocks. And after some while, I got an email from a professor at UC Berkeley, Dan Garcia, who said, Jens, we're working on this new course at UC Berkeley that is going to be called The Beauty and Joy of Computing, and we'd like to use your extension to Scratch to teach it at UC Berkeley. Would you mind? I said, of course not. This is great. Like, somebody uses this stuff that I've written. But then after a while, I got another email from another professor at UC Berkeley by the name of Brian Harvey. And he said, Jens, that's all great, but in order for us to teach block-based computing the way we need to teach it at UC Berkeley, you need to add one more feature. And it's the ultimate powerful feature. I said, wait a minute, the ultimate power is power of attorney. I don't know what you're talking about. And Brian said, no, there is actually something that is called the ultimate. It's a set of papers written in the 70s, and it is called Lambda, the ultimate. And I said, what do you mean, Lambda, the ultimate? And Brian took one of our mascots, this mascot in Scratch, it's called Gobo, and he drew something on top. And it's a Greek letter, lambda. And he said, what we need is Scratch plus lambda, and then we'll have the ultimate programming language to teach computer science with. I said, Brian, you need to be a little bit more specific for me. And Brian showed me an example of what he needed. And out of this, we started developing a fork of Scratch and then a re-implementation that has turned into this programming language that was first called BYOB, for Build Your Own Blocks. And then because some parents in the US didn't have a sense of humor, we had to rename it for something that didn't imply alcohol. And we asked kids what to name it, and they said, why don't you name it Snap? And we named it Snap. So this is Snap, and it looks just like Scratch used to look back then. It has, you all know it, here's a stage with an object, there is some scripting area, and here are blocks that we can do things with. And so all the blocks are always live. When I click on the move block, the arrow moves. We also have round blocks, and round blocks are functions, are reporters. And Brian showed me, what if we have 3 plus 4, and we click on it, we get 7. Big deal. So he said, what we now need is the ultimate feature. And the ultimate feature to Brian, since he is a Lord of the Ring fan, is a ring. It has to be the one ring to rule them all. So this is the special feature that we added to Snap, the one feature that takes care of all computer science. It's a ring. So here is a ring, and now if I put this block into the ring and I click on it, it does not get evaluated. It gets quoted. So the ring is sort of a protection against an expression for being evaluated. It is a package. It ringifies, or as we say, reifies something. So big deal. You can package something, and we can unpack it again by saying call. So now I put this ring into call, and I click on it, I get 7 again. And folks, this is the most beautiful thing in all computer science, because now what we can do is we can have an empty slot inside, and we can say, we're calling this with data. I said, wait a minute, what's this empty slot thing? And Brian said, this is like, when you're in school, and you're being asked, what goes into the slot? Well, it's the 5 that goes into the slot. I said, wait, I know what you're talking about. The slot has power of attorney. It acts on behalf of what gets passed in. So now we can say 3 plus 5 is 8. Or we can say, plus is 5. And you can see there is something nerdy when a function is applied to a number. But the magic happens with computers when a function is applied to lots of numbers, to data. So where did we get data from? Last night, I was taking a picture of this venue we're in, Schloss Hansenberg. And look at this. I can look at this and I can say, I would like to know the pixels of Schloss Hansenberg. And I get lots of data. It's more than 100,000 rows of 4 columns of red, green, blue, and alpha values. So I want to have a function that works with all of this. And for this, we have something in Snap that uses these rings. Here's the map block. It has a ring. And it applies any block to any data. So a table in Snap is really just a list. It is a list of over 100,000 records of 4 columns. So now I can write a function in here that transforms all this data. And I can write anything in here. So I can say an if clause. Let us say, what if the second item of that list is greater than, let's pick an arbitrary, let's say greater than 100, then I want the number to be 0, otherwise I want the number to be 255. Now I want to apply this function to all the 100,000 records, and I click on this, and I get a new list with only zeros and 255s in it. And you can kind of see the power where this is leading up to. We said, now let's look at how this actually looks like if we apply a function to large data. So I'm clicking on this, and watch what happens to Schloss Hansenberg. It becomes a negative black and white picture. When you think about this ring really is a superpower. It is something that, with this idea alone, we can create anything really. It is something that was invented by Alonzo Church, and it's called the Lambda Calculus. And it lets us do even more. And this has been the flagship project we've been showing off. We can now build a programming language in itself. So when we inherited Scratch, we also inherited the control structures of Scratch. And the control structures are usually what makes a programming language. You learn the if clauses, you learn the loops. Now, all of you who've done Scratch probably know that there isn't any while loop in Scratch. Like, what kind of language is that? It doesn't even have a while loop. We say, wait a minute. We're supposed to be able to do anything, including a while loop. So we can make our own block. The way how we make our own block is we define a new block. I can say this is while. It should say test, and it should perform an action. Now if I click on this, I'm getting a new block. It's here already, but it doesn't yet look like a control structure, so I can specify the inputs. The test is something that I want to evaluate at every iteration that is supposed to be either true or false. It is a ring, a predicate ring. And notice how this turns into a lambda. Get it? The ultimate feature. So here's one ring. And then I also need something that gets evaluated, that is also going to be an input, the action. That is the code that is supposed to run at every iteration. So now I'm having two of these lambdas, and I'm saying apply. I'm already having this control structure. I can now write a little script, which I say, okay, I want to get the pen down. I want to get a variable, and I want to specify that while the variable is less than, say, 300, I want my sprite to move the amount of the variable to turn 121 degrees and increment that variable by 1. And now, if I click on this, nothing happens because we haven't yet defined it. So this is how we define a control structure in Snap. First, this is packaged up. We want to find out whether the condition is true. So we say if, and remember we need to call it because it is a ring. If we call the test, we run the action. And now I've done this just once. So what do I do for all the other times? Do I need a loop? No. The way we teach it is we already know what to do all the other times. We use the while block on itself. We can say, and then keep testing and do it recursively. So I'm really excited because usually when I show this, I make some kind of programming mistake. We're going to try to run this and see whether it works. And it does work. Look at that. This is a programming language that, with just a few blocks, lets us build any control structure that you can imagine in a programming language. Brian was right. It truly is the ultimate feature. So, blocks have this magic capacity that they set your imagination free. You can build things with blocks. You can transform things. But there is a secret. And the secret is blocks also do something to the one who uses them. They also transform the creator. When we build castles, when we build pirate ships, not only do we build stuff, but the material turns us into architects, into designers, storytellers, or mathematicians. And so building is something that is closely related to the German word Bildung. And I'd like to just encourage all of you to, when you get home, pick up some blocks, build stuff, and watch out what it does to you. Thank you.